Welcome to This Explainer. I've been walking ultra pure water or UPW plant floors for, well, over 2 decades now. And in this industry, as you guys know, we deal with precise chemistry, incredibly high voltages, and absolutely zero margin for error. Today, we're looking at a true high-stakes survival scenario for your system, diagnosing and resolving CEDI module arcing. When you're managing a multi-million-dollar facility, an electrical short circuit inside your continuous electrode ionization module, yeah, that isn't just a tiny hiccup. It's a catastrophic failure. It can and will halt your entire production. So I'm going to take you through a clinical, step-by-step masterclass on exactly how to identify, isolate, and totally prevent this exact nightmare.
Okay, let's dive into this using a really strict diagnostic framework. Here's our roadmap. Section 1 is the anatomy of UPW. Section 2, the trauma, those nasty arcing symptoms. Section 3 covers hypothesized causes. Section 4 is our diagnostic investigation. Section 5, step-by-step treatment. And finally, Section 6, preventative care. Let's get to it.
Section 1, the anatomy of UPW. To fix the heart, right, you first got to understand the body. So let's briefly set the stage for exactly where we are on the facility floor. Every UPW plant follows a really rigorous sequence. Imagine we're walking the floor here. We start with raw water, push that through a multimedia filter, or MMF, and then a cartridge filter, just to strip out the particulates. Next, boom, it hits the reverse osmosis, the RO membranes. But RO just isn't enough for what we do. That's where step 5 comes in, the CDI, the continuous electrode ionization module. This is the absolutely critical stage that polishes the water right before it passes through UV treatment to finally become our ultra-pure product. We're talking resistivity greater than 15 mega ohms. The CDI module is really the delicate, highly electrified workhorse of this entire operation.
Now, what's really interesting about this slide is the sheer engineering density of this specific hardware. We're looking at the Ion Pure LX-CD module. Inside this unit, you've got alternating cation and anion exchange resins, membranes, a concentrate compartment, the whole shebang, all sandwiched between an anode and a cathode. We're using direct current to literally drive ions out of the water. It's a brilliant design, but, and this is a big but, it relies on an incredibly delicate balance of water chemistry and electrical current. When that balance fails, well, the results are explosive. Which brings us to Section 2, the trauma, arcing symptoms. When this module goes down, believe me, it goes down hard. Let's look at exactly what happens inside.
In our world, an arcing event, a short circuit, is defined as a violent electrical discharge. It's happening directly between the anode and the cathode. Typically, this massive high-voltage electricity is just looking for the path of least resistance, right? So it shoots through the concentrate compartment, or honestly, even worse, it arcs straight through dried-out ion exchange resin. I mean, it is literally lightning striking inside a water purification module.
And as an operator, the symptoms of this trauma are just terrifying. You might actually see visible sparks. You'll almost certainly have smoke generation. You'll smell that awful scent of burning plastic. Internally, the short-circuiting is just torching those delicate membranes, leaving you with dried, permanently burnt resin. Make no mistake here, an arcing event causes irreversible, permanent module damage. Best case scenario, you're replacing an incredibly expensive piece of equipment. Worst case scenario, complete factory shutdown and a massive, massive hit to your production yield. And this brilliantly illustrates the immediate danger. During operation, the electrode wiring inside these module junction boxes runs at an extreme high voltage. It presents a severe shock and fire hazard. When a module arcs, it is no longer just a water purity issue, folks. It is an immediate life safety and facility integrity emergency. Section 3, hypothesized causes. All right, so the smoke clears, the system is down, and yeah, the panic sets in. But as veteran operators, we have to pivot. We switch to a methodical mindset to isolate the variables. So we have to ask this fundamental question before we even think about touching a wrench. Why did the module arc in the first place? Electricity only jumps when it's given a bridge, or, when its normal path is completely blocked. There are really 2 primary hypothesized causes. Think of them as 2 different diseases that lead to this failure. On the left, we've got external feed issues. Say your RO system upstream fails, suddenly you get insufficient feed water purity. This leads to high electrical conductivity.
Essentially, the water entering the CDI module is way too conductive, and it creates this massive unintended electrical bridge between the electrodes. Now on the right, we have internal physical failures. Over time, maybe due to poor maintenance, scale builds up inside the module, creating solid conductive paths. Or alternatively, a lack of water flow just dries out the resin completely, leading to localized overheating and internal membrane rupture.
Moving into Section 4, Diagnostic Investigation. Knowing the potential causes is great, but a seasoned engineer never guesses. We verify the data.
The absolute first investigative step, look at the water that went into the module right before the failure. The feed conductivity strictly must be under 10 to 20 microsiemens per centimeter. If your logs show a spike above this threshold, well, you found your culprit. High conductivity water hit a high voltage field, and boom, it flashed over.
But we don't just look at a single snapshot. You absolutely must review your manual operational log sheets. I know, nobody loves paperwork, but they are mandatory for a reason. They ensure consistent operation, and frankly, they're required for module warranty claims. Track your historical feed conductivity, monitor your CO2 levels. Carbon dioxide can actually artificially inflate that conductivity. Also look really closely at your recent cleaning regimens. We need to figure out whether scale or foulants are allowed to build up over time, basically constructing those deadly internal conductive paths.
Section 5, Step-by-Step Treatment. All right, once the root cause is identified and corrected, which is usually an upstream RO failure or maybe a bad flushing protocol, we transition to the actual surgery. Let's safely recover the system. Let's move to and see how this builds our strict, non-negotiable treatment plan. Step 1 is absolute. Disconnect and lock out AC power according to your standard lockout/tagout procedures. Never ever touch that junction box live. Step 2, verify that your RO permeate feed water quality is actually back in spec. Step 3 is absolutely critical. Execute a pre-startup flush. You've got to ensure no air or concentrated debris is trapped inside the module. And finally, Step 4, recalculate your DC current based on the exact flow and conductivity so you aren't overdriving the module when you fire it back up.
Now, during this recovery phase, you might need to check the module for leaks caused by the trauma of the arc. You can use a torque wrench to carefully check the tie bars, start at 10 foot-pounds, and make sure you never exceed the specs in the manual. But heed this warning, please. Never, under any circumstances, attempt to open the LX module yourself. I mean it. Opening the module will cause irreversible damage to the internal seals and membranes, and guess what? It'll completely void your warranty. Just don't do it.
So, the crucial point is this absolute golden rule of CEDI maintenance. As you're treating your system, maybe flushing it with chemicals to remove scale, you must ensure the DC power is positively off. Running cleaning or sanitization solutions, which by the way are highly conductive, through the module while it's electrified, that will instantly cause the exact arcing event we're desperately trying to recover from. Finally, Section 6, Preventative Care. So the system is back online, it's stable. How do we keep our patient healthy for the long haul?
I've essentially distilled 20 years of plant experience into this really simple, actionable checklist. Honestly, every facility engineer should have this pinned directly to their control panel. First up, execute a pre-startup flush before every single start to clear the lines. Second, continuously verify your feed water remains well below that 10 to 20 microsiemens threshold. Third, strictly mandate power lockout to 0 voltage before you do any maintenance whatsoever. And finally, update those log sheets daily. Those logs aren't just busy work, they are your early warning system before a catastrophic failure actually happens. Look, an arcing event is violent, it is incredibly expensive, and it is almost entirely preventable. Don't wait for the smoke. I want to leave you with this to really think about today. Are your current pre-startup flushing protocols actually protecting your multi-million-dollar UPW plant? Or are you just one bad RO feed away from a total factory shutdown? Go check your logs today. Thanks for joining me in this explainer, and hey, stay safe out there on the floor.